Okay, I've unmuted the audio, and so I should have something here. Let's see. Looks like I've got unmuted there, so I'm ready to go, it appears. And I'm recording to this machine. All right, as I mentioned, and put an announcement here that November 15th, which is Wednesday, would be pre-recorded. And I mentioned I posted that announcement, and of course on Monday the 13th we covered everything up to decision. We started on decision analysis, which is chapter 13, and we did it by covering the PDC project up to sensitivity analysis. And so that we had walked through that and if you have your book, you really should take a look at the PDC decision tree. And the decision tree is really nothing more than a payoff table just inverted and put into the format of a tree with its different branches. And you have, and they're talking about here. They're talking about doing a marketing research study, and this moves us into some of the issues like a decision strategy, or what we would talk about in terms of sensitivity analysis. So we put together that decision tree, and if you take a look up at page 619, figure 13.7, you'll see the influence diagram for the PDC problem. And with some sample information, you can see we have a research study, complex size. Some of that's controllable, some of that is not, which I like demand, and then obviously what we see in terms of the results. Now, if you go over to page 620, if you figure 13.8, you will see the decision tree in all of its glory, with using strong demand, medium demand. Now, what's not happened at this point? Those are raw data because we've not attached probabilities to the outcome. A payoff matrix, what I would call a raw or unprocessed decision matrix, would be one where we show decisions, we show states of nature, but we don't assign a probability to them. In other words, we have an inferred probability, which is going to be 1 divided by, for example, the number of conditions, and 1 divided by the number of alternatives or choices. Okay, so for all intents and purposes, we've got that, we have that situation going on. Now, if you come over to page 621, you're going to start to see some decision strategies, and this takes us into using these data in a very practical way. And for example, here they show us, and this is page 621, if the market research study is undertaken and we'll get a favorable report, 0.77, or an unfavorable report, 0.23. And then we talk about the market research report is favorable. Okay, the demand for favorable report 0.94, weak demand 0.06. Excuse me, my tongue is all tied. And then we see if the market research is unfavorable. So we looked at, do we just do it? Is it favorable? Is it unfavorable? Or we don't undertake it. So we're here now in the middle of page 620, we talk about doing a market research report, okay? And anytime you enter into a capital project, you're going to do some kind of report, and you're going to make some assumptions about demand or your alternatives, okay? And so when we do that, we are building in some decision strategies. And they show us relating the nodes over there, okay? Nodes 6, 7, and 8 assume a favorable report. And those are, the 6, 7, and 8 are back over there, are back over on figure 13.8. So they're referring to those nodes, okay? And then an unfavorable report, they show you the 3 nodes there, 9, 10, and 11. And then the report not undertaken are nodes 12, 13, and 14. So we're talking about doing a market research study or not doing it, and then we plug it into that process. And the tree lets us see the logical flow of what's going on, okay? And we have these, if you look over, and now you can look over to figure 13.9, you can see the the decision tree with branch probabilities. We've attached those probabilities, and those are the ones that are mentioned at the bottom of page 621, excuse me. So 622, that just shows you in the tree diagram with the optional actions, what we believe to be the actual conditions, and we attach probabilities to them. Now, there on page 623, we see the expected values. And anytime someone says an expected value, okay, they're making an assumption about two things. One, they're making an assumption about the conditions, and two, they're making an assumption about the alternative or the action that they choose. And we see that we're talking now about a market study. Market studies are important. Now, we consider them a sunk cost. If you talk about a capital project, because it's money that we're going to spend, whether the project is undertaken or not. Okay, so I want to talk about that first of all before we come and double back now and talk about sensitivity analysis. And so double back over now to page 614, and they talk about sensitivity analysis. Okay, and what it really means is we say, okay, which of the variables, okay, give us the largest change in outcome, okay? And over on page 613, you see the risk analysis profile and the sensitivity study, okay? And so you'll want to take a look there at the bottom of page 612, where they talk about the condominium project and how it might proceed if we had the value of perfect information. Okay, so we've looked at all that, and again, 611 and 612 walk you through what things look like if I have perfect information, okay, based upon probabilities and alternative actions, okay? And so we can take that and get the expected value. There at the bottom of page 611, they show you how to get the expected value, okay? And if you'll notice that you had 0.8 times 20, in other words, a condition of strong conditions, and we get the best payoff, and then we take the worst conditions, okay, and the lowest payoff there. And you'd have to see the table back on 13.5 to see the data. And that gives us 17.4. So the expected value of this with perfect information, okay, is 17.4. Okay, and this again, the expected value perfect information is what would we attain? What would we get if conditions are as we believe them to be? That's where that 0.8 comes in at the bottom of page 611. Or if they're not, and we take the best payoff and the worst payoff, and we combine the two of them to get the expected value of information. Okay? Now, as the authors go ahead over on page 612, and I apologize about the didacticness of this, but you really do have to kind of walk through the chapter, okay, and see this. The expected value of the perfect information is 17.4. Okay. The expected value without perfect information is 14.2. So, and this is at the top of 612. So the most that we would pay for a research study would be 3.2 million. Okay. That's the most that we would pay for the expected value of information. So anything up to that point, okay, as an outlay, we would do. Okay. So that helps us put in perspective sunk costs, particularly those involving research, market research. And if you're a marketing student, you really ought to zero in, okay, on this chapter, especially when we talk about the expected value of information. Once we have that, then we can start to move over into risk analysis, okay, and we talk about that, and then we do the sensitivity analysis. And we flip what the authors in the middle of page 614. What the authors did was a pretty typical technique in terms of dealing with the sensitivity analysis. They flipped the probabilities. Okay, and I'm in the middle of 614, and you ought to have your book open and be looking at it and maybe making some notes, not in the book because you won't sell it back, but on your own. And if you'll notice there, for example, the expected value of decision 1, and we have the lower probability of states of nature plus, okay, the higher plus our lowest value, and that gives us 7.2, 6 point, and then we get 6.8 and minus 3.2. We compare them, and that tells us that the most sensitive is the one that, in terms of demand to 3, okay, and that we're talking about the largest demand, and that's the most sensitive of that, and our assessment of it. Okay, so you can just flip those probabilities and see how you come out. And you see a sensitivity analysis, you have 7.2 versus 7.8, you have 6.8 versus 12.2, and then you end up with minus 3.2 versus 14.2, which is 17.4. So that's the most sensitive. So the issue that the thing that is the most volatile or subject to variation is demand level. And if we go back when we started the chapter, and we talked about it, and we showed the influence diagram, we have things that are controllable and things that are not. It is within our control to build the size of apartment complex and price it and furnish it and all that. What's not within our control is the demand. Now, a marketer would say, well, no, wait, that's not necessarily true, because we can do advertising and we can do marketing and we can impact the demand. We can try to create demand, or we can go after people who are demanding a similar product. Okay. And so what I'd say is fine, then you have to go back and add in advertising costs. You have to add in, PR, any of those marketing costs to get the project going. Those are really become sunk costs. Okay. And often what you'll see in the capital budgeting is people will take those costs and they'll filter them out over a period of years. The truth is, you're going to spend a whole bunch of money as you're building the thing, and once you have it built, just to get people to come and stay, come and live there. Okay, and so you have to take into account that you may affect the market demand. Okay, but you can be problematic. Now, let me say this: most real estate developers, here's how they handle the problem. They front load demand. that they'll get an anchor client. You know, if you go by office buildings and you drive by and you'll see the name of a company, typically that company is an anchor tenant. That it looks like they own the building, but they really don't. Okay, their name's up there, all right, on the building, but they don't own the building. They're leasing it probably from a real estate developer, from a commercial developer. Okay, and they front loaded the demand for that developer by saying, okay, we'll take the first 2 floors and then you lease out the rest. But if you do that, we're going to give us a bargain. Okay, so that's how that demand issue is mitigated out in the real world. Okay, well, you can see it. You know, it's not all completely cut and dried. All right, and you know, as they walk us through, okay, there at the bottom page 614, they talk about the states of nature, okay, and the probability. And as they, you know, and with, you know, with 2 states of nature, the probability of S2 is the difference between 1 minus S1, okay? And the probability of S1 is 1 minus S2. The probabilities have to add up to 1. Now, as I mentioned in the Monday lecture, when you see a raw table that shows states of nature, typically along the top, and then alternative responses to those states of nature, or actions, or choices. If you don't see probabilities attached to them, then you're assuming equiprobability. Okay, and that just doesn't pass equal probability of conditions. Okay, and that just doesn't pass. It just doesn't pass, you know, the muster. It doesn't pass the smell test. It should never pass your smell test. Let's put it like that. You should see that and you go, oh, somebody's not thinking. Now, you probably could maneuver some nice language to say to people, yeah, we have an expected payout table, but maybe we ought to go back and look at this. Are we sure that the conditions are equally probable? Okay, and that's really the jockeying. The rest of this, the math is pretty simple. You know, it's the expected value. The expected value is the value that we would get with an alternative times the probability of that occurring. That's really all this boils down to. Then sensitivity analysis says, okay, if I flip conditions like we did there, what does this look like? Okay, and notice the way we flipped them was we took the largest outcome with the lowest probability. Okay, and that's an easy technique to do, and that's what the authors do, and that's what I would recommend as a practical chance. If you get into a situation where you've got several possible states of nature, okay, then what the authors, you know, the author's prescription for that is take the smallest probability times the largest outcome. Okay, and then take the largest probability times the smallest outcome, and that kind of washes it all out and gives you a picture of the expected value, and lets you analyze what's the most sensitive thing. Now, that being said, the next step for you, this is my belief, is to go and put together your project budget and put together a cash flow statement, or do a capital budget and randomize outcomes. Okay, randomize them and see what does it look like. All right, because you can see those risk profiles that the authors showed us are a little bit different. So this chapter, the mathematics in this chapter are no big deal, okay? Now, one of the things that we've done in this chapter that's different than we did with the Foreman text, you remember when we did the Foreman text, okay, and we did the case using naive Bayes, we just assumed that the states of nature, okay, or the probabilities are independent. And so we just multiply the probabilities. That becomes a little more complicated when we assume they're dependent. And so do we get much better results assuming dependencies? Maybe, maybe not, which is why so many people use naive Bayes. And I have a book I refer you to that talks about this. I show you some examples of where we use naive Bayes. And of course, we did that case where we use naive Bayes. Okay, so it's there's a tendency sometimes for people to, let me say this, if you had a random number table, okay, and you ran and you simulated, let's say 1,000 probabilities, okay, and then you simulated 1,000 alternative outcomes. All right, you could take them, and then you're saying, okay, what do I do? Well, you're probably going to take the average, okay, of the probabilities. You'll probably take an average of the expected outcomes. All right, so there is a point where you're splitting hairs. You're not really accomplishing much. Okay, and that's one of those things. You got to remember that expected value table, a budget, anything like this, a human being has inputted the data and has made some judgments about things. All right, and if you're looking at this, say for example, this building, these apartments, the PDC that project, I would say that the most obviously the greatest sensitivity is going to the factor that contributes to the sensitivity or volatility is going to be demand. So you'd better really have a handle on that. You can control how much you build. You can control what you're going to spend. Okay. And so one of the things what the authors have done here in this chapter 13 is they've shown you expected values based upon states of nature and payoffs, okay? But you could also take a second, and I recommend you do a second step. Do expected probabilities of costs, okay? In other words, what is it going to cost me to build that building? Now, the authors don't go into that, but you can look at costs in the same way. And then you start to see, all right, in fact, you could do it in terms of cash flows. Then how will the cash flow look? And you can build a cash flow budget on that basis. So those are just some things you kind of learn the hard way. And you got to remember, all of this walks itself back to type 1 versus type 2 error. How much am I scared of a false positive versus a false negative? And I think especially when you're talking about construction projects, you always want to think about a false negative. Why? Well, when you've built it, you've built it. Okay? And better you expect growth and then not get it than you expect growth, then better you don't expect the growth and you get the growth. So you have a real tangible reality to deal with versus expecting the growth and not getting it, a false positive. That can be highly problematic. Well, as the authors walk us on through risk analysis and the sensitivity analysis, again, in the middle of 614, they do sensitivity analysis, and I call it poor man's sensitivity analysis. You just flip the probabilities, the highest probability, the lowest outcome, lowest probability, the highest outcome, and you compute them, and then you start to get the differences. And they show you that over there on page 615, and through those equations using. And then over on page 616, figure 13.6. And you said, Dr. Harmon, you really are going through the text, aren't you? Yes, because you really do need to read this text in full, and you really need to see it to absorb what they're talking about. And again, I've said this over and over. Decisions are not binary. They're not right. They're not good or bad, white or black. They run along a continuum of really, really good, or really, really bad, or kind of what we expected. Okay, and that's just, that's that probability distribution. As you can see over in figure 13.6, they show you, okay, the sensitivity analysis, okay, and the expected value. They show you a function that illustrated there, okay, showing you expected values in terms of the low, which demand level provides the highest expected value. Okay, and while that might seem like, well, if you look there at that table, what you're going to see is the expected values driving the kind of outcomes that you get. And the rest of this is, and the rest of the chapter walks us through this. Now, over on page 618, the authors begin to talk about using sample information, okay? And they mention things like raw material sampling, product testing, market research. These are experiments, okay, or studies, and they deal with what they probabilities they call posterior probabilities, okay, and this harkens us back to chapter 1, where we talked about the difference between decision making and problem solving, and harkens us back to chapter 1, where we talk about building a model, okay, and we can. The easiest is a mathematical model if I have enough real world data to support it, okay? And if you pop over to page 620, you see the full tree, okay, including the market research study. The market research study is intended to act like sampling information, okay? And then as we started out, when we started the lecture, we're back over to page 621, we've made that circle back, okay? And you almost have to think like that process to bring yourself back to where you've got some decision strategies based upon the report. And the rest of chapter 13, just basically walks you through that, the decision tree. Just why it's just nothing more than a payoff matrix, just inverted into a tree, so you see flows or branch probabilities, if you will. Okay, same thing with 1310. And then you look, and then at page 1311, you've winnowed things down to the best decisions, okay, based upon expected values. And then you reduce it to 2 conditions, okay? So you see as you cull through these. And through figure 13.3, figure 13.4, they walk you through branches with optimal decision strategies, okay, have perfect value of information, how do I end up? And you can see the payoffs, they're in the middle of page 626, and the probability of those payoffs. All right. Now, the authors move us into a little bit more esoteric territory over there on page 628 when they start to talk about the efficiency of sample informations. Okay. And we take the expected value of sample information, and we divide that by the expected value of perfect information. Take that times 100, and that gives us an efficiency measure. So we create a ratio. Okay. Now, again, if you look at the decision tree here, okay, again, page 629, you'll see page 630 walks you through how that's all constructed. And it brings us back over to page 630 to a payoff table, a true payoff table that shows us outcomes and probabilities. Okay. And the same thing over on then in table 13.7, they show us the branch probabilities based on a favorable market research or an unfavorable market research, which is at the bottom of page 621. Now, you'll notice I've done a whole lot of lecturing here, far more than I usually do. And we've not popped out the file, okay, to play around with this. And you can do that if you choose, and it's just go back over to the files section, okay? And we'll come on down here to the MS-13. We'll find that zip file. All right. And come down here. It's going to be MS-13 web. Here it is. I'll download it. And we'll open up chapter 13, get the Excel file, and there's the PDC tree. And it's starting, and it's at its starting point. And again, you could extend this on out if you chose to. All right. I think the authors provide you so much illustration and so much tabular data that you can just kind of see, all right, here's how I would get started with this. Okay. And again, some key things to remember. First of all, no matter how beautifully you lay this all out, you'd better make sure that you have a good handle on the probabilities of certain conditions. Okay. Now, like I said before, you could do a random simulation of outcomes, okay, and a random simulation of probabilities, excuse me, and a random simulation of probabilities of or states of nature versus the expected versus the payoff, and you could randomize both. Okay, and so you could simulate that thing. And I'm one of those that says it's probably not a bad idea. Okay, to see the range of what you get. Now, that's assuming that you don't know. Now, here's what happens. A lot of people, okay, do this by the seat of their pants. Because this really, if you want to say, well, how would I do capital budgeting? This chapter really covers how you would do it. A lot of people will go by the seat of their pants. They'll take a hunch. They won't have data. They'll buy a piece of property. They'll build it. The only thing will fill it. Okay. And the controllable part may or may not be the costs. So while the probabilities, you would want to look at those range. The thing you have to look at is, okay, especially on that would be the costs because those are things that may or may not be in your control. You might assume certain things about materials costs that are just not there, okay, that just don't happen. And again, this is one of these things while you plan for the worst, hope for the best in that particular situation, okay. Better you have a false negative type 2 error than a false positive, because if you have a false positive and you build the condominiums and assume that you've got strong demand, you have a white elephant on your hands if the demand wasn't strong. And that really takes a highly informed person. And let me say this: if you're a marketing student and you're really serious about your craft, you're going to dive into chapter 13 and take a deep dive and learn everything you can, read everything, go back over this lecture, go back over the textbook. Okay. If you're a finance major, you ought to be doing the same. Okay. If you're a management major, same thing. If you're thinking you're going to work out in real estate development, you probably want to buy this book and keep it. Okay. Because what you're going to find is so many people fly by the seat of their pants. They have a hunch that things will open up as they do. Now, let me give you a good example. One of our faculty bought a new home as it was being constructed in a new housing addition. Now, we know that the value of property in a new housing addition fluctuates according to a couple of things. First of all, the market for housing in that area, plus perceptions of the desirability of that location, because you've heard the thing about real estate's location. And the same thing that works its way through in residential is the same thing that works its way through commercial. So if you're one of the first people there in the subdivision, and you have all this empty space, and you don't have any construction going on, or very little, okay, I can guarantee you that a prospective buyer is going to take a look at that, and they may think twice. It would be the same thing as if you build an office building without an anchor tenant, or you build a strip mall without anchor tenants, and if you want to kind of get a picture of that, you can go around some of the strip malls there in Shawnee and take a look and see where things are thriving and where things are not, and ask yourself, what happened here? Well, probably what happened was somebody forgot to look at things like the direction of traffic at a given time, because we know people, when things are busy, people are reluctant to make a left turn into traffic, so they'll go on down. And traffic flows north, south, east, and west, that type of thing. Those are things that you learn and you gain through experience that the textbook kind of alludes to, but really can't take you there. Okay. Now, I have admittedly, glossed over a whole lot of this. Okay. And so I think one of the things I would encourage you to do would be to take a look over there at some information about the medical screening test at Duke University. You see another one of these dealing about type 1 versus type 2 error, false positives versus false negatives. They've got they have another example with Oglethorpe Power Corporation, OPC. Okay, and they use expected value analysis. What you're going to find is larger firms and better companies will use these techniques. Now, a lot of them will do it by the seat of their pants. It's in their head, and they'll work through these kinds of things. I'm one of those people who says, if you're embarking upon something like this, then you really should run. You really should perform these steps, okay? And in the business I've been in, for example, in education, I don't know how many times I've sat in a room with people saying, well, okay, let's start this particular program. and nobody's done any real market analysis. Nobody's done any analysis of the cost. Nobody's even taken the time to run, to simulate out the results. Okay, and and if you're going to do business, like particularly projects, you have to do this. You can't assume that you have control over anything, including costs. You just can't. So you have to say, okay, I'm living in an uncertain world. How uncertain could it be? And base your decision strategy along that way. Well, that's pretty much it. Okay, as far as the PDC tree, and if you wanted to, okay, you could change some of these probabilities. Okay, and we're looking at, and you want to look at the, we start off with small, medium, or large in terms of the condominium. And I'm going to press on this again. I showed you this the other day, where we say, okay, what's the maximum? And the maximum is the sum of E6, E16, and E26. And that is if we build small, okay, or if we build medium, a medium-sized complex, or we build a large one. And again, we got low demand, high demand, or strong demand and weak demand. And the authors have made this very simplistic for us. If you really want to see the decision tree in its glory, go back through chapter 13 and take a look at those. Okay, and you'll see what they really are. A decision tree is, as I said before, is nothing more than a decision matrix, a payoff table. Okay, but it's just inverted, so you see the branch probabilities. Again, understanding that probabilities have branches, okay, because actions have consequences, and consequences have more consequences. And we talk about this, the law of unintended consequences, okay? So that would be pretty much it in terms of chapter 13. Now I want to look and see what I might have asked you to do with this. So I'm going to go over here and close these files down. Okay, move you guys over here. And again, that's in there. Then that web file is chapter 13. And pop over here to the syllabus for a moment. Let's see if I gave you any instructions on this in terms of uploading it. If I want you to manipulate some data. And let's find what's due the 10th. Well, we had Hammond's Port. Okay, there's the 17th. And I asked you to upload the file, okay? And I don't give you any kind of instructions I'm seeing. Let me go to the modules and look for a second and see if I gave you, ask you to manipulate one of those variables. Okay. Let's see if I do that. No, I didn't, because I felt like you've got enough stuff in the book, so I didn't. But if you want, you can open up that 13 and play around with it. Change those probabilities, 50, 50, 82, or flip them if you wanted to see the probability, if you wanted to do a sensitivity analysis. And I also want to just takes a little bit of time here to talk about all of these different resources I've given you, okay? In addition to chapter 13, which does an incredibly good job of talking about decision analysis and bringing it down to a level that anybody can use. As I said before, the math's not difficult. It's the thought process, okay? And you've got to understand that, I can build you a beautiful payoff table, but if I have garbage, I've got a beautiful can of garbage. So again, remember, these in the real world, those costs or results based upon weak demand, medium demand, strong demand, whatever. That should be backed up by a whole lot of relevant research. Okay, now I'm going to talk about that for just a minute here. We have a tree plan example. Okay, I'm going to download this and show you for a second. Okay, and this is from 13. And you can see here, as they walk this through, and it's rendered out pretty nicely. If they prepare a proposal, this is a company trying to decide if they're going to bid on a project or not. And you want to download and take a look. You can see the branch probabilities and their alternative choices and the payoffs. Okay. Let's go back and see how that nice tree plan example. And I also wanted to make sure that after you've looked at chapter 13, which I think if look, when you're out there playing around with other people's money, okay, you better make sure that you know what you're doing, because if you don't, things get ugly really fast, okay, especially on a capital project. If you mess up on a capital project, it can hurt you terribly, because capital projects tend to have high strategic value as well as high monetary value. So, if you blunder, you're in trouble. I have learned, okay, this is just me, I've learned over time that people will projects will get a political kind of aspect in the company, and everybody will say, well, we're going to do it because the boss wants to do it, we're going to do it because our competitors are doing it, etc. So I want to make sure that you think clearly through that. So I've got some things here for you, okay? And these also, these deal with the chapters on prediction and forecasting, and that's over chapter 14, okay? Talks about multi-criteria decision making, okay, and then estimation. And so I have a link here for you that explains the difference between estimation, extrapolation, prediction, and forecasting. And you want to understand those differences. They're subtle, but they're very important. And I have a link for you to that resource. The authors don't really talk about that, but the truth is they're all operable and they're all very different. Now, also have a resource for you in terms of the relevant cash flows for a capital project. And I know for most of you, you fought your way through Intro to Finance, okay? And you said, thank God I'm through that, I'll never do it again. Well, if you got anything from finance, if you did capital budgeting, okay, or if you got anything from business problem analysis when you took it with me, we're going to get you caught up right here. You need to understand the fact that when I do capital budgeting, I must have the relevant cash flows. Those that change, those that increment changes in profit, changes in costs, changes in personnel, whatever, the relevant or the marginal outcomes produced by that project. That's why we talk about sunk costs. So you have to have you have to have the relevant cash flows. Okay. Now, I took 2 courses on capital budgeting. Okay. I took one from the guy who wrote the gold standard textbook on capital budgeting, etc. And then the second was from a guy who was with Southwestern Bell and AT&T and did all their capital budget projects. He oversaw them. So I was very fortunate. But the one thing they did, they drilled it, tattooed it on my forehead, was relevant cash flows. Now, here's just a link to a short course in super forecasting. Then here's some resources for some people who do a pretty good job of this. The Good Judgment Project, Nate Silver's 538. And I think Nate Silver is somebody worth going to see about once a week. because he's very good, and he's very good at taking all kinds of data, all kinds of situations, and providing forecast data, and then explaining it to you in layman's terms. But before you do anything, go back and look at this resource and look at the difference between estimation, extrapolation, prediction, and forecasting, because they are subtle, but they have subtle, the differences are subtle, but exceptionally important. Well, that's going to do it for this for this chapter 13. Okay, and before I and I'm going to say this, and then this is the pre-recorded screencast I promised you I'd do for Wednesday. And we want to talk about what we've got coming up, and just to kind of keep the flow going on the week of the 20th, and the 20th, 22nd, and the 24th. All right. There's no class on Wednesday, the 22nd, or Friday, the 24th, because of Thanksgiving. So we'll have a class on Monday. Now, I may, and I haven't made the decision yet, I may do a screencast on Monday. All right. I'm just not sure if I'm going to do it yet or not. Okay. But there will be no screencasts for Wednesday or for Friday. That's Thanksgiving holiday week. Okay. So I'll probably go ahead and just do the regular Monday thing and come in and do the broadcast. And then I have some materials here for you. Okay. Because we'll be working on the AHP Excel case. Okay, and that'll be due on Friday, December 1st. That'll be the next week. So I didn't have anything due that week. And we'll talk about bounded rationality and satisficing. We'll talk about Pareto efficiency. Look at the reciprocal lattice, weighting by pairwise comparison. So we're gonna move into the realm of forecasting. Okay. And of all of the places where I think probably we don't do very well is that. Okay, but this is your opportunity to kind of get caught up. Then you'll see in Module 14, okay, this starts with the 27th. Okay, that's flex time to work on, we won't have any classes that week because it's flex time, so you can work on course projects in the final exam. Same story with module 15. And you say, what projects? Well, here they are. SAT. Okay, and then the Anderson text, the SDQ, that'll be due, and then you have your finals. So on the 20th, starting the 20th, I'll do a screencast, and then from there on out, okay, those will be flex time. So I won't be coming online or doing anything. You'll be working on the SAT business project, and then your finals. And I really encourage you to make sure, okay, because I have some of these final exam part A is due at the start of the final exam period. B is due at the end. You've had classes with me, you know how to do this. I've got instructions and screenshots and all that. Okay, my friends, thank you so much for taking the time to take a look at this. I think chapter 13 is maybe, I think that chapter 13 is perhaps the most important chapter in the entire book, with the exception of chapter 1, because it makes us come to grips with the issues of our estimates, probabilities, states of nature, and understanding the strategies that we've chosen most of the time companies will choose a strategy. They don't even know they've chosen it, okay? And I think if you understand about expected value, the expected value of perfect information, the expected value of sample information, you'll be far, far ahead. And as opposed to just creating a tree diagram and crunching numbers, it's a way of thinking. And I can't emphasize that enough. And so when you plug it into the idea of we need models, okay, then chapter 13, so what are the models that are out there to help me understand how demand might be? And what are the models that might help me understand costs? You know, one of the reasons that we have you learn some cost accounting is you're going to be involved with running a company. You're going to absorb costs. So you need to understand them, which is one of the reasons why in 1123 I walk you through the issue of, total costs, fixed costs, variable costs, and contribution margins. Well, things all kind of come together in this course in some interesting ways. And again, thanks so much, and I will stop the recording and save it, and then I'll post it, and this will be for your Wednesday, November 15th class. Okay. So I'm going to stop the sharing, and I'll stop the